This video is going to go over counting atoms notes. This page should be in your notebook. We talked about this a little bit last unit, but this is going to get a little bit more in depth and help prepare us for balancing equations later on in the unit. A molecule is made up of multiple atoms. So something that we call a molecule is going to be anything that has more than one atom. Over on the right side of your paper, I have some basic instructions. The first thing that you want to do anytime you're given a chemical formula is figure out what elements you have. So in this example, we have O, which is going to be oxygen. Anytime an element symbol is written in a chemical formula, that means that there's at least one of those atoms present in that formula. If there are no other numbers, there are only those letters, then that means that there is one of each of the elements that are listed. So on this picture we have carbon monoxide, a C and an O, and there are only one of each of those elements present. On the left side of your paper, we'll work through examples for each of our steps. So this first example has just our letters with no numbers, which implies that there's just one of each of those elements. So we have magnesium, which is our Mg, and oxygen, which is our O, and there is one of each of those elements. So the next thing we're going to look at is something called a subscript. A subscript is the little number that's written to the lower right of an element, and that indicates that there is more than one of that particular element. The second step when we're counting our atoms is to find any subscript and apply that to the element. So in our example on the right side of the paper, our oxygens, it's O2, so there are 2 oxygens. The second example on the left also has subscripts. It says how many atoms are in C2H4. So our first element, C, is carbon, and there are 2 atoms because it has a subscript of 2. And our second element, H, is hydrogen, and there are 4 atoms because it has a subscript of 4. All right, so some atoms are commonly found together within a compound, things like OH, which is our hydroxide group, or there are other common groups that are found in atoms. Because of this, a lot of compounds have parentheses that indicate that particular group is inside of a compound. Outside of the parentheses, there could be a subscript, and that indicates that there is more than one of that group present in the molecule. If there is a subscript outside of the parentheses, you would multiply everything inside of the parentheses by that subscript number. So once again, on the right side of your paper, our example, O2, if it was in parentheses with a 2 outside of it, we would do 2 times 2 for 4 oxygen atoms. And then back to the left side of our paper, we have an example with parentheses. How many atoms are in NH4 2s? So our first element is nitrogen, and there's a 1 that it has as a subscript. You would then multiply it by the 2 outside the parentheses to get 2 atoms of nitrogen. H is hydrogen, and it has a subscript of 4. Then you would multiply that by 2 for the 2 outside of the parentheses. And then our last element, S, is sulfur, and that doesn't have a subscript, and it's not inside the parentheses, so it would just be 1 atom. So the last type of number that you would see would be a coefficient, and then that's something you've talked about in math. A coefficient is a number that's out front, and in a chemical formula, it's a number that's in front of the whole formula, and that indicates that there's more than one of that entire molecule present. So when a coefficient is present, you're going to multiply the number of atoms in each element by that coefficient. Every atom that is in the molecule will be multiplied by that coefficient. So for our last one on the right side of our paper, we now have 2 O2 with a 2 outside of the parentheses. So we would take our subscript 2, multiply it by our 2 outside of the parentheses, and then multiply that by the 2 coefficient. 2 times 2 times 2 is going to give us 8 atoms of oxygen. On the left side of our paper, we have a coefficient example and how many atoms are in 2H2O. Our first element, H, is hydrogen. It has a subscript of 2, and we have that coefficient of 2. 2 times 2 is 4 atoms of hydrogen. Our next element, oxygen, has no subscript, so we assume it's 1. and then you multiply that by the coefficient of 2, so there are 2 atoms of oxygen. Now, when all of the different numbers are present, you're going to apply each of those 3 steps, and you'll go in the order that we talked about them. Look at the subscripts first, then the parentheses, then the coefficients. So if nothing else, remember that order. Subscripts first, then parentheses, then coefficients. And you're going to multiply. So pick your element, look at its subscript, look at if it's in a parentheses or not, and does it have a coefficient. Every time you should check those 3 things and multiply them together. So we've got 2 more examples on the left that go through all of our steps. The first one is how many atoms are in 3NH42S. So for N, nitrogen, it has a no subscript, so 1, times 2 for those parentheses, times 3 for our coefficient out front, so 6 atoms of nitrogen. For hydrogen, we have our subscript of 4, our 2 for inside of our parentheses, and our coefficient of 3. So 4 times 2 is 8, times 3 is 24 hydrogen atoms. And last, our sulfur does not have a subscript, does not have a parentheses, but it does have that 3 coefficient. So we will have 3 atoms of sulfur. The next example is how many atoms are in 4COOH2. So cobalt, our first element, it doesn't have a subscript, so that's a 1. It's not inside the parentheses, but it is part of the molecule, so it is going to be multiplied by that 4 coefficient. So there are 4 atoms of cobalt. Oxygen is our second element. It doesn't have a subscript, so that's a 1. It is inside the parentheses, so times 2. And it is after the coefficient, so times 4. So 1 times 2 is 2, times 4 is 8 atoms of oxygen. All right, and hydrogen is just like our oxygen. There's no subscript, but it is inside our parentheses, and it does have that coefficient out front. So 1 times 2 times 4 is 8 atoms of hydrogen as well. So the last bit of our notes is at the bottom, and that's our chemical equation. This is an example of a chemical equation, sodium hydroxide and hydrochloric acid, and those form water and a salt. That's review from our acid-base neutralization. But we're going to look at this as any kind of chemical reaction. Every chemical reaction has some parts that you're going to need to label. So everything before the arrow in a chemical equation is called a reactant. And those are the things, our starting materials. Those are the things that we start with when we do a chemical reaction. Every chemical equation also has an arrow, and that arrow is telling us that a chemical reaction is happening, or that our reactants are chemically reacting to form the rest of our equation. And then every chemical equation also has products. Products are everything that are to the right of the arrow or at the end of our chemical equation, and that's what is formed by a chemical reaction. So every chemical equation is going to have reactants on the left, or our starting materials. They chemically react to form our products or our ending materials on the right.